microscopic plankton and algae lived, died, and rained down in a constant biological shower, blanketing the ancient ocean floors. This diagram illustrates geological burial. Eons of shifting tides piled layers of sand and mud on the organic matter, sealing it. The Earth became a natural pressure cooker. Tons of sediment pressed down, while core thermal energy rose, chemically transforming the trapped remains. Under this intense heat, the biological bonds shattered. The organic molecules recombined into hydrocarbons, the carbon-rich chains that form the basis of crude oil. Crude oil is a geological battery, concentrating millions of years of solar energy into a dense, liquid form. To find these batteries, geologists use seismic surveys, sending sound waves deep into the ground. By analyzing the patterns of the echoes that bounce back, they can map where oil is trapped between rock layers. Once a reservoir is identified, engineers deploy rigs capable of driving a drill bit up to 4 kilometers deep to reach the hidden reserves. Puncturing these depths is dangerous. The underground pressure is so high that a single structural failure can lead to an explosive blowout. To maintain control, engineers circulate a heavy fluid called drilling mud down the shaft. This mud acts as a liquid shock absorber, cooling the drill while suppressing the massive pressure from below. When the drill bit breaches the reservoir, pent-up energy forces crude oil violently toward the surface. Engineers call this the first breath of the well. This process is essentially humanity piercing the planet's veins to release a million-year-old reserve of energy. Raw crude is contaminated with sand, water, and gas. It must be transported to refineries, sprawling industrial sites where the oil is physically and chemically reorganized. Refining begins with fractional distillation. Crude is heated to 400 degrees Celsius and pumped into this column, turning into vapor. As it rises and cools, components condense. Asphalt at the hot base, diesel in the middle, and petrol near the cooler top. Separation alone isn't enough to meet demand. Using high heat and catalysts, engineers crack large, heavy molecules into the smaller, lighter ones needed for high-performance petrol. Through reforming, the chemical structure is tweaked to raise the octane rating, ensuring the fuel burns smoothly without causing the engine to knock. In the final stage, toxic sulfur is stripped away. This prevents the fuel from corroding the engine and reduces the pollutants released into the atmosphere. The refinery takes nature's rough chemistry and reorganizes it into a fuel specifically tuned for the internal combustion engine. Refined petrol is now one of the most volatile and dangerous liquids on the planet, requiring constant oversight across its entire journey. It travels hundreds of kilometers through high-pressure underground pipe networks that are monitored 24 hours a day to prevent leaks or pressure drops. These lines deliver the fuel to tank farms outside major cities, where millions of gallons are stored in massive, temperature-controlled reservoirs. The final journey occurs on civilian streets via specialized multi-layered tanker trucks designed with safety valves and anti-static systems, isolating the fuel from external sparks. When you reach for a pump handle today, you're interacting with the very end of a massive global logistics network. Nature takes millions of years to forge this material, and we spend billions of dollars to extract and refine it, only to burn it in a fraction of a second inside an engine. We are now facing the reality of shrinking reserves and the high environmental cost of releasing this stored carbon back into the atmosphere. We are entering a multi-energy era, where petrol must share the grid with electricity, solar, and hydrogen. While the dominance of petrol is receding, every liter pumped today represents millions of years of geologic processing, serving as the high-density energy source that fueled a century of global growth. Every second, the global economy burns thousands of gallons of fuel. Cars accelerate onto highways, jets push through the stratosphere, and heavy machinery keeps industry moving. But to maintain this speed, we are burning the remains of the ancient past. The energy thrusting a plane forward was captured millions of years ago by microscopic sea creatures drifting in prehistoric oceans. We pull this energy from the crust as crude oil, but in its raw state, it is a thick, foul-smelling sludge. It is corrosive, unrefined, and completely unusable for a modern engine. How do we take this raw biological memory and engineer it? Picture a desolate landscape at night, illuminated only by the harsh floodlights of a towering rig. Giant steel machinery forcefully bores into the rock. working relentlessly to extract the thick, black liquid that fuels global travel and industry. But crude oil doesn't start as a mechanical or chemical process. To find its true origin, we have to drop deep beneath the sand and travel back millions of years. Before humans, before dinosaurs, ancient oceans were packed with microscopic life, trillions of tiny plankton and algae. These tiny organisms survived by doing exactly what plants do today. They absorbed sunlight. They pulled in solar energy and stored it within their cells.